Hello, I'm Charlotte Ray from the University of Sussex in the UK. In this talk, I'm going to consider the environmental impacts of open science with a particular focus on the issues of neuroimaging datasets. And I'm going to start with a disclosure straight away that actually I don't know what the exact footprint of open neuroimaging is. But this talk is aiming to help us take a step towards answering that question by highlighting some of the issues that as a community I think we really need to consider. I think probably everyone here in the Open Science Room, and actually now probably most colleagues in the field at large, would agree that open science is pretty much a good thing. But there are hidden costs. Some of these are the time and effort that it takes to upskill, and the disproportionate burden on early career researchers who are often in vulnerable employment positions but who we expect to lead the work. I'm also very concerned about the potential sustainability costs, by which I mean the environmental impacts. And there are particular issues that come from working with MRI and MEG data because of the large file sizes and the fact we need liquid helium to acquire the data. And I'm going to focus on these two specific issues of sharing large data sets and acquiring magnetic imaging data, which have slightly different implications for the most sustainable routes to open neuroimaging. And after I've explained why these may be issues, I'm going to give an overview of the current state of play in terms of the green credentials of popular repositories like the Open Science Framework and Neurovault. I then want to end with possibly quite a controversial suggestion that actually I think we might need to be reducing the amount of scientific activity we're engaging in. And then I'll wrap up by talking about plans for a new environment special interest group for HBM. Okay, before I get onto the open science issues, I want to first bring everyone up to speed on the scope and scale of the environmental challenges we're facing. And everyone here is a scientist, so I think everyone has good familiarity, for example, with what the climate emergency means. But just to make sure everyone's on the same page, I'm going to briefly outline the seriousness of the situation we're in, borrowing slides from Extinction Rebellion. And I also want to place a trigger warning here that you may find aspects of these distressing. So we know that greenhouse gas emissions have skyrocketed since the Industrial Revolution. This is the famous hockey stick graph showing the very steep increase in atmospheric carbon dioxide. And you can see emissions are gathering pace all the time. Now the consequences are that global temperatures are also skyrocketing, and we're now at 1.1 Celsius over pre-industrial temperatures. The Intergovernmental Panel on Climate Change is a UN-backed body of climate science experts, and they've been telling us for over 30 years that this was happening, that we needed to act, and if we didn't, the consequences would be catastrophic. 18 months ago, the IPCC released this seminal report saying that we had 12 years left to take rapid and drastic action if we were going to stay within the 1.5 degrees Celsius limit agreed by the Paris Accord in 2015. We're now down to 10 years left, and we're yet to see much robust action taken by anyone in line with that target. And we also don't have to look very far now to see what 1.1 degrees of warming feels like. And I can tell you that from my perspective in the UK, this year we had one of the wettest winters ever on record and floods, followed by one of the hottest springs ever on record. I'm sure wherever you are in the world, just looking out of the window, you're seeing and feeling effects. And these effects are already disproportionately being felt by the global south. Now, if we don't limit our emissions in line with IPCC targets, the consequences are that our weather systems will become so unstable, we will not be able to grow the food we need to feed 8 billion people on this planet. The inevitable consequence of this is mass migration and armed conflict. This is going to happen within our lifetimes and within the lifetimes of our trainees. I also want to flag that climate change isn't the only issue. We're also destroying the planet's ecology. For example, by taking land that other creatures have been living on and repurposing it for our own needs. And I'm flagging this because it relates to a point that I'll make about mining of finite natural resources to manufacture electronic equipment. And the issue for us is that by destroying biodiversity on such a global scale, it also impacts the resilience of our planet to provide us with food. So I wanted to set the scene in terms of recognising that these environmental catastrophes are happening now. we must act urgently, and that the causes driving these problems extend across all areas of human activity, and scientific research is one of these. So let's get on to the relevance to open neuroimaging. To engage in open science practices, we use servers to store, share, and interact with data. And this engenders a number of issues across construction, mining for limited resources, and energy. And I'll now look at these in detail and then at issues relating to the specific types of data we use. Now, data centres have a large carbon footprint. And this paper gives an overview of the numerous factors relating to data centre operation that cause CO2 emissions. And in fact, it's much more than just the day-to-day operation of the centre, although that is very large. It's a whole life cycle impact from the manufacture of servers, their transport, through to end-of-life disposal. Let's look first at just building the data centre, because anytime you build something, that construction work uses natural resources and it creates carbon emissions. And it also takes land that otherwise might support other organisms. But let's say we think this is an okay price to pay to get the thing built in the first place. Well, then we need to manufacture all the electronic equipment for the data centre. And this is primarily the servers. And in this list here, just look at all the resources that are needed to manufacture servers. Some of these are metals which are in limited natural supply on this planet, the only planet we've got, such as copper. And importantly, to get these limited natural resources, we need to mine for them. Mining involves essentially extracting natural resources, often in a way that involves habitat loss or destruction. And also a lot of mining nowadays is happening in developing countries where there might not also be tight oversight of human rights. Some of these resources are non-renewable and difficult to recycle, such as plastic that's made from oil. So the extraction of these components has an environmental impact before you even get to the fact that their assembly into a server has a carbon footprint through the energy required for the manufacturing process. Oh dear. Let's now come on to server operation. And this is possibly where the highest climate impact is. Because to store, share, and interact with data, that requires energy to power the servers. And not only that, we need energy to cool the building. Have you ever felt your laptop heating up on your lap as you stream a TV show? Well, that tells you that high energy computing processes create heat in that computing equipment. So server rooms have to be air conditioned, and that takes further energy. There are three key factors that affect how much energy we use. And first of all, it's how much activity we engage in. The more we store, the more we share, the more we interact, the more energy is required to support that open science. Secondly, location. Putting data centres in the middle of the Californian desert is not really a good idea, because inevitably you're going to have bigger energy requirements to cool the building. And thirdly, efficiency of the system. And details here, I have to admit, are a little bit beyond my own personal expertise, but there are things to consider, like whether to run a local system or use the cloud, where you may well gain efficiencies of scale. Now, where does the energy that we need to power our open science come from? In a worst case scenario, it's coming from fossil fuels: coal, oil, gas. And by the way, the IPCC says we need to radically reduce and rapidly transition away from fossil fuels, and that we need to do this in the next decade if we're going to stay on track for 1.5 degrees C of warming. In the best case scenario, whichever repository you're using runs on renewable energy instead. So in that case, at least your open science isn't directly relying on fossil fuel energy. However, remember the points I made about server manufacture requiring natural resources. The same goes for manufacturing renewable energy machinery, like solar panels and wind turbines. And we have a limited amount of resources on this planet to make these. Also, we have to consider the space that we take from nature in order to construct a solar farm or a wind farm. So this tells us that actually, even if you're using renewable energy for your open science, it's still important to minimise demand. Again, even if you're using renewable energy, there's an environmental impact in the life cycle of the servers. So these numbers are again from the data centre paper, which assumes a 10-year lifetime and 2 IT refreshes. And that sounds to me like an awfully high turnover rate. But this is just the pace of technological change that we've become accustomed to. Is that really appropriate when we have a limited amount of natural resources to make these machines? Now, a lot of what I've just covered relates to any of our online activities, whether it's streaming Netflix, online shopping, Google searching, these all rely on servers. But my feeling is that as neuroimagers engaging in open science, I want to make the point that we almost certainly disproportionately use server resources compared to the average citizen. And this is in part because our data files are so large. So let's now think about the typical size of data set that we're using nowadays. If I acquire my own multimodal MRI data set on a moderate number of people, let's say 100, then that's running into hundreds of gigabytes of files. The Human Connectome Project Young Adult, if you were to get the whole data set, that's hundreds of terabytes. And the UK Biobank, all of the raw imaging data, that's petabytes in magnitude. As a side note, you possibly wouldn't be accessing petabytes of the biobank data as a data consumer, and probably you're only taking some of the sequences that are maybe on the order of terabytes, or if you're using the imaging-derived phenotypes that Fidel, Carla and Steve have helpfully processed for us, then that would reduce file size substantially. But seeing the size of these data sets, maybe you start to get a feel for why, as neuroimagers, when we acquire and then further share our data sets, there is a substantial server footprint. So, this leads me to my first conclusion. The more you store and share, the bigger your footprint, even if your data centre runs on renewable energy, because of the manufacturing processes involved in all the equipment. Okay, I'm now going to sort of flip this around and instead pose a question around whether acquiring less data but sharing it more freely may instead be a better approach in terms of environmental impact. So let's transport ourselves into an MRI magnet room. And you know that background whoosh sort of pumping noise you hear? That's the liquid helium pump that supercools the magnet. And without liquid helium, we wouldn't have a functioning scanner, as anyone who's been around when a magnet quenches will have seen. Where does that liquid helium come from? It actually occurs as a substance in the natural world in gaseous form. And in fact, it pretty much exists largely in deposits of natural gas buried within rocks deep in the earth. To my knowledge, there's currently no way to manufacture helium. This means the only way we can get hold of liquid helium for our scanners, whether that's an MRI scanner or a MEG scanner, is by drilling for fossil fuels. And we get the helium as a byproduct of that fossil fuel extraction. And we know, the IPCC have told us, there's a very limited time span left during which we can legitimately continue extracting natural gas. So we're looking at an uncertain future for how we can power our scanners if we are going to leave those fossil fuels in the ground. And regardless of peak oil, liquid helium is by definition a limited natural resource. So I think this raises the question of whether we should be valuing the MRI data that we collect much more highly. And that brings me full circle to open science and data sharing. I think we need to have a conversation as an OSR community about what's really important to share under what circumstances, given the large footprint associated with doing so. And my instinct is that much as I might love the local data I'm acquiring for my specific research question, does it really have high utility to others in the field particularly if I'm investigating something very niche and specialist. And certainly it's not going to be of much interest as the field-leading open neuroimaging data sets like the HCP and Biobank. So I'm not convinced that it merits taking up space on servers somewhere if it might never get used by anyone else. The Biobank, in contrast, I think is an interesting one because it's kind of at the opposite end of the spectrum with petabytes of data. But I think it probably has, in my opinion, the biggest potential of any endeavour ever conducted in our field to generate really unique cognitive neuroscience that we couldn't get any other way. So my feeling is this probably does merit its place on energy-hungry servers, but it may be by only taking what you really need as a data consumer, rather than all the raw data. That would take you down to gig and terabytes over petabytes. Although we do need to keep in mind the implications of having multiple local copies of biobank data at each institution where there's a PI accessing the dataset. On balance, my instinct is if you could reuse the biobank data for your exact research question, then that might well be better from an environmental perspective than acquiring your own data with the helium and resource issues. I also want to touch on some ideas that we've heard about from other OSR talks last week. And several colleagues mentioned the concept of storing data in one place and then just accessing it remotely to perform calculations from your end without ever actually copying the data. Emma Blumke, for example, talked about open mind and how to ensure privacy by accessing data from different institutions without actually sharing the data so that you don't have to download the whole data set. And this could well save us on-server storage space. However, when I talked to Emma about it, she did raise a warning flag that actually the privacy techniques might come with certain overheads in terms of energy requirements, so it may be that it's not quite so green after all. We also heard from Eric Werner about CoinStack, which is a method by which you can pool data from multiple sites, but without making a central remote shared data set. And so this would help both in terms of overall storage and not transferring large amounts of data. And these are certainly, I think, interesting developments that I hope we can think about further as a community, both for the open science benefits and the potential environmental benefits too. So my second conclusion is, it may be that reuse of existing popular data sets rather than acquiring your own may, under some circumstances, lower your footprint. And on the other hand, I have a pretty strong instinct that sharing an average quality data set that has limited interest to anyone other than you may not be worth the carbon price. But let's say you do think your data has high reuse potential and you want to share it. What are the green credentials of our main repositories? The Open Science Framework uses Google data storage, and luckily Google use 100% renewable energy. And what they mean by this is that for all the energy consumed, they pay a renewable energy supplier to generate that amount of energy. This information is publicly available, so if you go to the OSF FAQ webpage, there you'll find a mention that they use Google, and then if you go to Google, you'll find that they confirm the servers run on 100% renewable energy. Now, I had to do a bit more digging with two other repositories, Neurovault and Open Neuro, because this issue wasn't specifically covered on the FAQ of their websites. So I got in touch with them directly, and first I found out that Neurovault uses Amazon Web Services. And if you go and look at the Amazon web page, link at the bottom, you'll find that as of their most recent update, only around 50% of their server activity is run on renewables. And for some particular server locations that aren't covered by that 50%, instead Amazon offset the carbon emissions. And I haven't got time here to go into offsetting in detail, but I really want to emphasise offsetting is extremely problematic for a number of reasons. I'm happy to talk more about that during the Q&A. Neurovault told me that, in fact, their default data centre is in Oregon. Unfortunately, this is one of the Amazon locations not running on renewable, but as a result, happily, Neurovault are actively currently looking into switching locations, so that's a good outcome to look forward to, and we might soon be able to change that orange flag to green for Neurovault. Finally, let's say that you really do want to share your full data set on a repository like OpenNeuro. When I asked, OpenNeuro told me that they also use AWS, although I didn't get any extra information on the server location. So it's possible this still isn't running off renewables. Therefore, my third conclusion is OSF is currently the green standard repository. I'm also inviting you to ask yourself, is sharing summary fMRI results on Neurovault sufficient? Do I need to take up gigabytes of storage space sharing the full raw data on a repository like OpenNeuro if no one's ever going to use it? Could it be that smaller storage space on Neurovault for just the summary is appropriate? Now, the final point I want to raise for discussion, possibly this is going to be the most controversial, I think we may need to actually fundamentally reduce our scientific consumption first and foremost before we attempt to mitigate any footprint of data acquisition and sharing. And there's this 3 R's phase from the world of recycling that says actually recycling is the last resort. First you should reduce, so try to avoid consuming in the first place, and then look at reusing before recycling only once there's no possible further use. And I think this also applies to open neuroimaging. There's also this idea which Jutta Frith recently talked about in a TIXA opinion piece earlier this year of slow science. And she argues that we need to do less but better science and actually consider restricting our outputs. So maybe there are holistic multiple benefits to reducing the amount of neuroimaging we engage in. And as I come towards the end, I want to wrap up with some rather serious reflections. It's clear there are environmental ramifications of open science practices, although the details, at least to me, are still not entirely clear. If there's one thing you take away from this talk, I'd like it to be asking yourself, what do I really need to share? And how can I best do that in a way that minimises the environmental impact? We need to have a difficult and honest conversation about reducing consumption and the scale and pace of the changes required. We don't have tech solutions for the climate crisis, and offsetting is not appropriate. We really do have to lean into the challenge of making big changes to how we do things. And if we don't lean into that challenge, the biggest we have ever faced as a species, then we are not going to be able to do science full stop, and that is going to happen within our lifetimes. I'm going to end really with a call to action. I think many here might be going away from this feeling a bit confused over what the right thing to do is. Really, we need a formal, quantitative analysis specialised for neuroimaging that would guide us through making judgment calls over whether to acquire data, whether to share it, how to share it. And I think this could be a priority action for a new OHBM Environment Special Interest Group. So I'd like to invite you to join the new Environment Sig. Follow the link for sign-up details. The SIG would look at environment impacts of the annual meeting, but it would aim to do much more than that and take a wider collaborative approach to working out what we need to do as a community to minimise the environmental impact of neuroimaging research, with open science being just one strand of that. So I hope you'll join me on that journey. And if you're interested in joining the Environment Sig, whether as a committee member or just to go on the mailing list for updates, please follow the link to give your contact details. And if you've been inspired by today's talk and would like to read further, here are some suggested resources. 2 specific to neuroimaging and 2 that are broader. And you can get the slides on the GitHub abstract talk page to follow all of these links, including the one to sign up for the Environment Sig. And I'll put the GitHub link in the Crowdcast chat so that everyone can follow that link to access these slides and all the resources contained within them. Thank you very much for taking the time to listen today, and I look forward to answering any questions. And I hope you'll join the new OHBM Environment Sig.
So if it's all right with you, I'll jump in and field the Q&A.
Thanks, Cass.
Thank you. This is kind of like a topic close to my heart in terms of environmentalism. And we all like to think, well, a lot of us are trying to do our best. But I'll admit that I had never really considered it in terms of how it impacts my own workplace. Like, we've got posters around the corridors saying, switch off your lights and recycle paper. But so much of what you discussed was a completely new thought processes for me. Like, helium comes from drilling for fossil fuels. Like, turn off my magnet, right? So let's get going. So does anyone want to come up with a first question? Otherwise, I've got a few that we can chat about for a few minutes while people are. Just give us a wave in the chat if you want to come up. I don't know. Cooper had some questions.
There's a question.
Lovely.
Should we all be switching to EEG?
Okay, so I think there's a number of answers we can think about for that. One point that I didn't make in the main talk about MEG in particular is that in relation to the liquid helium issue, is that MEG, squid MEG anyway, boils off liquid helium at a faster rate than MRI does. So actually per data set, squid MEG uses a much larger amount of helium than an MRI data set. And so the first question might be, if you're thinking about MEG versus MRI, it might be MRI has the lower footprint. But then this question raises the possibility of, well, if EEG is appropriate for your research question, it's not going to require the same level of resources in the acquisition. And I have never used EEG myself, so I don't feel particularly well qualified to comment on the analysis implications, but my instinct would be that there are probably still similar issues relating to storage space on servers, amount taken up, and particularly if you're using a very high density channel system where you've got 128 channels, then there's going to be much more data. You know, our data sets just keep exponentially increasing and increasing over time, and I'm sure EEG is similar in that respect. And then we come to the specific issue that we're all here for in the OSR of sharing the data. And again, maybe if there are any EEG colleagues, they could come in and comment on how they're sharing EEG data and if there are ramifications of that in terms of large file sizes.
I'm minded of the whole capitalist consumerist society, and when you talk about MEG like that, it feels, and like comparative to EEG with maybe MRI roughly in the middle in terms of the like acquisition costs, it feels like the more technologically advanced we go, the more we have to consume things to do these amazing feats. And you know, there's something weird in there about, like, in order to be better we must consume more, and that's just a whole other side project and discussion. But anyway, Cooper, did you want to jump in your question?
Definitely.
And Lee, we can definitely come back to that if you want to discuss that later. Go for it.
Can you hear me properly? I'm on data. I'm not sure it's okay.
Yep, we can hear you.
Charlotte, great talk. That was amazing. This is a topic that's very close to my heart, so it's really good to see some visibility on it. So to me, like, thinking about environmental issues like climate change, it's really a collective action problem. Like, we can only really take action when all of the governments agree to take some kind of action together. And so for me, it seems like we're going to have the same problem in academia, because we've all got selfish motivations and goals that we want to achieve. And so then we're going to have to organize some kind of a collective action amongst ourselves to make progress. Have you thought about what kind of, I guess, agreements we could come to, or what sort of like parameters we might talk about agreeing upon?
Awesome. Well, yeah, thank you so much for attending the talk, and everyone who's been attending. And I'm just so delighted that it's not just me talking to myself in an empty room anymore. You know, we've really seen seismic changes. I've been in an environmental campaign all my adult life, and I've never known anything like what's happened the last 18 months in terms of awareness. So I think the awareness is increasingly there, but there's this massive gap between the awareness and action. And I think exactly as you've touched upon, the difficulty is turning this massive juggernaut around requires everyone in the world to get on the same page and agree on concrete actions. And ultimately, this is a political problem rather than a technological problem. How can we do our bit within the neuroimaging community as, you know, a sphere within that global community? And my idea at the moment for how we could go about is to use OHBM as a platform and give us a framework and a structure for international collaboration. And having seen what the Open Science Special Interest Group have been doing and putting this whole event on for us, kind of inspired me to think, okay, maybe this is a way we can start collaborating internationally to have difficult discussions around what actions we can be taking. So I also want to get this Environment Sig up and running, because I get the impression, again, partly from how the OS Sig has been running, it's very much a team effort. And teams who collaborate and who are diverse, because we know diverse teams bring more knowledge and make better decisions. That's how we can actually create consensus. I hope by structuring activities in Environment Sig, we can come up with a list of actions that might be promoted, say, on the OHBM blog, that might be talked about in future conferences, and ultimately might lead towards us, you know, with mass co-authoring papers that, you know, in a similar way to how there's been lots of open science papers coming out the last few years. I won't name names because there's just so many now, but you know, setting out visions for what do we need to do to get there with open science. And the more we see these things being published, the more it creates this community sort of feeling of, oh my gosh, everyone else is doing this, I'd better get on board. But it needs us here to kickstart that and start leading that process.
I think we saw a similar thing with SFN. Charlotte and I talked about this already, but where there was an SFN petition about conference travel and things like that. So I think there's a reasonably powerful message that we can put out as a community, saying that this is something, first, like, how many other people also don't know the things that we've all learned today, and what message could we send by, as a organization, raising these issues publicly and saying we don't know what the answers are, but we want to try and move forward with it. I think it's I think it should be a great platform.
Definitely. Thanks, Charlotte.
If you have any other ideas, please put them in the chat.
Yeah. So we have another question from Hao-Ting, asking, are there any other grants, that expect us to, that don't expect us to collect data and use open access data exclusively? Off the top of my head, I don't know them, but I know that there are people who get funded to use Biobank, for example.
So I'm wondering if Fidel might be able to inform us specifically on the biobank. To my knowledge, and my knowledge is very biased as someone who's only just become a PI in the last year and only just started putting in grants, and also someone who's based in the UK and is familiar with UK funders. To my knowledge, there aren't any specific calls within the UK that are neuroimaging data science oriented. However, I'm convinced that many applications are going in currently to make use of Biobank as one open imaging data set. I want to make a sort of tangentially related point around making sustainability points within grant applications. So one of the things we have to do in making grant applications nowadays is write this thing called a data management plan, where you talk about how you're going to curate the data, and it's trying to lead the grant applicant by the hand towards open science practices without formally stating that as a requirement. And what I've been doing in my recent grant applications in data management plans is outlining the thought process that I've just given you guys in the talk, and ending with a paragraph saying, however, there are sustainability implications to this. For further information, please see the discussion on my lab website. And I'm just trying to get that sustainability word and angle in there to promote the agenda in that data management plan. And it's my hope that then when peer reviewers read that grant application, when the panel of 20 people read it, they go, oh, that's a thing. And it all, I think, just helps elevate this to higher levels of awareness throughout the academic community. Hao-Ting, I don't know if you have any comments you want to make on grant applications specifically for open data.
Yeah, so that question came from partially a very selfish place, because during my PhD, I reused one data set for 2 chapters, and I used open access data set. And during my postdoc, I am continuing using other people's data set and open access data set for all the studies. So, but one of the expectation I'm sensing is just PIs will still expect ECRs to collect their own data. And yeah, and right now I don't really know what is the best way forward to put my argument forward. And I think Charlotte's talk really gave me a new perspective on how I can start to like have this conversation with people, or like when I'm writing grant application. And another thing is I am very into managing data efficiently and using computing resource efficiently. So I do feel in order to push the environmental friendly agenda forward, one potential good thing to promote is how to teach people to use use computational resource efficiently. One personal experience I had at my previous institute was people didn't realize the data was all stored and backed up in a centralized location. They don't need to copy the data off the machine to do the analyses. They can create a symbolic link on the Linux system they provide and do analysis all there, because they are going to use the Linux machine the center provide anyway. And transferring data, as after the data is acquired, transferring data and computational resource is going to generate, it's going to use up more energy than simply just storing the data over there. But this might be a more difficult hurdle for most people to get through, because you are asking them, you need to learn to use computer more efficiently, and that's not what everyone wants to hear, unfortunately. Yeah.
I think Fidel's comment actually fits quite nicely into this, what you're saying now, where he says that it would be good if there's funding for a lab to do processing on demand for the UK biobank, but in for other data sets.
A single places.
Yeah.
I just wanted to add add into this. I think it's part of the same thought process about reproducibility, and we're thinking about like not running too much, not running more analysis than you actually maybe need to, or like thrashing your data through every type of model that you can think of, which in terms of what we're talking about today is really wasteful. And this is also completely aligned with reproducibility and transparency. And it's like, decide what analysis you're going to do, make sure that's the correct and appropriate analysis, take lots of consultation to form your question, your data collection, and run that analysis. You know, stop the temptation to crash it through every kind of model you can think of. I think it's really interesting how the two kind of angles are really aligned here.
Yeah.
Sorry, Charlotte, I interrupted.
Well, no, so there are several points there that I think I'd like to revisit and come back to. So Hao-Ting, you raised the point about PIs often want to acquire their own data. I'll give my viewpoint as someone who's just become a PI and someone who is currently wanting to work on the biobank data set. So my PhD student Raul Ungarianu is leading on this. And some of our questions can be hopefully very well answered by that data set. However, having just suggested to you guys that we either need to, we need to minimize what we're doing and we need to, pick one approach that has the minimal impact, and biobank might be better than acquiring your own data. Unfortunately, we're all hypocrites, right? All human beings wanting to work on sustainability are hypocrites. I am also about to, in the next year, hopefully start my own batch of local data acquisition. And the reason for that is that I'm particularly interested in task FMRI, and the specific tasks I want to run aren't available in the biobank. So I'm taking a dual approach, which for me is the right scientific approach to get the combination of insights, but I'm not convinced it's at all environmental to be doing so. And I think there's a lot of issues with power dynamics in academia that we touched on in the chat, actually, with a lot of intersectionalities with sustainability in academia. And as someone who's only just made the leap, I feel like I don't have the historical experience to give you a true insight into why PIs aren't willing to listen to you in that respect. But I feel like the HBM community, and here's one example of it, is very bottom up and is very mass participatory, and is about increasingly, I think, about giving voices to early career researchers. And so I think that will be a really key strand that we should have running through something like an Environment Sig. Your other point about we need to teach colleagues how to really, oh God, yeah, and I'm acutely aware that I feel I'm actually at a very low skill level with that. And there are numerous barriers to this. And one is at the individual level. Some people just aren't keen on it. And we're not all natural programmers, and we've all got different skill sets. And science works by being collaborative because we all contribute different skills. But nevertheless, as individuals, we really need to try and upskill on this. But a barrier is institutionally, this can be very patchy. So if you're somewhere like the Win in Oxford, I don't know, maybe Cass can tell us, but possibly these sorts of things are being laid on for you. Whereas I know at Sussex, where both Hao-Ting and I are, there isn't this kind of training available institutionally. Perhaps this is another action the Environment Sig can take forward, maybe in combination with the OS Sig, about providing open resources, open training that we could make available to the whole community. Of course, that means ECR like you have to do all this extra unpaid work, but this is perhaps something we can look at within the Environment Sig. Fidel made the point about biobank. It would be good if there was funding for a lab institution to do UK biobank processing on demand. Well, Fidel's gone now, but I think we know who the best people are to do that. And Cass, your point about reproducibility and not running millions of unnecessary analyses, absolutely. What I've started doing in my transition to running a new lab with Raul, my PhD student, we're writing pre-registration analysis plans for our biobank analysis. We're putting them on OSF because OSF runs on renewables. And we'll see if we manage to actually restrict the number of analyses we run through using this open workflow process.
Yeah, that would be great, because I do most of my analyses on open access data set, and it would be great to see other people's analysis plan on this kind of data set, because that is also a missing market in the registration, pre-registration part, yeah.
So we have a few other questions. One is from Eleanor. Some papers require data to be available online. How can we reconcile transparency and reproducibility and environmental concern?
So I guess it probably varies a little journal by journal. And I haven't yet published anywhere that has formally required me to share the data. Everywhere I've been publishing the last couple of years, it's just been you have to make the data availability statement. And what I've been doing is putting behavioural stuff on Open Science Framework because it's run on Renewable. One of my recent publications was a psychophysiology study that didn't have imaging. So I didn't use Open Neuro, I put it all on OSF. And I felt uncomfortable at the time because the physiology is gigabytes in data size. And I'm thinking what I might do going forwards is like maybe write a little README of, I haven't put all the physiology up, but if you want it, let me know, kind of like a pull request on GitHub. So I'd really like to kind of see that added as a feature to repositories like OSF, like Open Neuro. With a specific issue around neuroimaging, so far what I've been doing to meet those requirements for journals is I share all my summary fMRI results on Neurovault. So far, I have not shared any of the actual data sets on something like Open Neuro. One, because I just feel so uncomfortable about the sustainability implications. Two, because I'm basically still publishing what I'm thinking of as legacy data that's in relatively specialist niche populations, and I'm just not convinced it's high quality enough or of enough wider interest to merit that. But going forwards, I'm going to have to confront what I do with my hopefully nice new quality data. And I'm hoping, and going through this process has made me think I'm going to actually suggest to Open Neuro that they put something in place for a pull request such that I can say, I've got all my data sitting on my local servers and here's a screenshot to evidence it or something. If anyone actually wants it, do a pull request and only then will I upload it and take this. Oh, Ben's telling me that is in place. Awesome. Thank you very much for updating us. That's data IA LED. Oh, okay. This is why we're here in the Open Science Room, because it's a room that's for collaboration and skill sharing. Brilliant. Thanks, guys. So Ellie's question about funder requirements. Maybe there will be a way by which you can use that data lad process to say, I'm willing to share it on request. And maybe you can write a sentence somewhere to get that sustainability angle in.
Cool idea.
So we've got so there's Cooper, if it's okay, we've got just 10 minutes left, and I know a few other people have got questions. So if it's okay, we'll cycle through those other questions and come back to you if there's time, Cooper.
Sorry, Stefan, I'm talking a lot.
No, it's great. I think it's awesome that there's so much discussion around this, and I'm not sure if we've yet, thank you, Cooper, I don't think we've yet got a Mattermost channel set up for this, but sure. Let's say it's going to be called OSR Emergent Enviro or something like that. We'll set that up and we can continue the discussion there. Stefan, Stefan's secretly telling me that he's got a question as well. Do you want to come in with yours?
I mean, I can also just speak. No, so with open science, there's also a lot of like signaling happening. So when you speak about open science badges or data availability statements in papers, and to some extent they're great, and to some extent they can be misused or just like used as a signal to say I'm doing open science, I'm cool or whatever, but actually not, or maybe it's just a neutral thing. It's not good nor bad. So I'm wondering, and also the other thing is like if people like, for example, they say the study was pre-registered, then are we supposed to think like, okay, that this makes the study better in some moral way or something? So the problem is that you can misuse pre-registration as well. You can report different variables afterwards. So the point I'm making is that it's more complex than just saying I'm now doing open science. And I'm wondering if you can see such like what's the word?
Parallels.
Yeah, such parallels in the environmental. I don't know the right terminology to use, but
No, absolutely. So I think virtue signalling is a huge issue in sustainability, and the last sort of 18 months was this thing about flight shaming. We're now operating in a different sphere in terms of aviation, and this is a wider discussion for another time. But there was this sort of flight shaming thing around, your huge carbon footprint from flying. And I find this very unhelpful, because it's not collaborative, it's not in the spirit, it's not in a team spirit by which we're going to have to achieve this together. Everyone's somewhere on a spectrum. I may be at one end. I recognise that everyone else is on journeys along that spectrum, and it's not helpful. And I think the same, there's the parallel for open science. Everyone is on an open science journey, sitting somewhere along a spectrum, and it's not helpful, those of us who have got more experience, pointing to others and saying, "Oh, you're failing. This is not good enough." So I think we have to be very careful in the language that we use. It is very nuanced, it's not black and white, but my is by talking about these things in more nuanced terms, we avoid the kind of failure to pre-registration shame, and we avoid the flight shaming, and we avoid the virtue signalling. The badges, I think, is a very interesting one, because at the back of my mind I've been thinking, well, another thing the Environment Sig could do is to quantify a process by which you could calculate what the carbon footprint of your study is. And then on your HBM poster, with all the names at the top, you could have a logo with a footprint saying this study cost XYZ tons of carbon. And that would help us weigh up as a community, wow, okay, this poster is amazing, but it took however many tons. Or this one didn't take so many tons. Why is that? But as soon as I had that thought, it worried me that there'd then be this poster off, this poster virtue signalling, this poster shaming of, oh, did you see poster 969 with its 3 tons of carbon?
Yeah, that's my general fear of like putting a metric on something that's way more complicated than a single number or picture.
Yeah, I think it's Goodhart's law as well, isn't it? It's like every time you create a metric, it will be ruined by someone somewhere. So in the final few minutes, Charlotte, I wonder if you want to give us some specific calls for action, like things we can do in our own institutions. I know you mentioned that you're a member of your own IT department's working group, and then of course there's the intention to join the new e-cig, which isn't a vapor device, it's the environmental SIG. If you want to add the link again there, and we can put it on the Mattermost channel. I think the intention is for first just to sort of gather interest, like see who wants to continue considering this and seeing what we can do in a ground up way from within our organization. But anything else you'd like to add, Charlotte?
Cool. So whenever anyone asks me, what can I do? I always say there are 3 levels that you can operate on. One is the individual level. And if you want to calculate your individual carbon footprint, on my lab website, there is a link to a calculator if you scroll right down to the bottom. And this also applies to us as individual scientists. If you've been inspired by what you've heard today, take this away and think about what you can do as an individual. But as Cooper, I think, brilliantly made the point, as individuals, it's not going to add up. So then there's stuff that you can do on the sort of second tier up of organising collectively within your local community. So that's what's going on in your institution. When I started as a PI at Sussex last year, I asked if we could create a new admin role for me of faculty green officer. So I actually have now some of my job time ring-fenced to doing sustainability activities within psychology at Sussex. And that's in part what's enabled me to spend the time to prep this for today, because it all comes under that remit. Have a chat with senior colleagues in your department. If there isn't a green committee, why isn't there? If there isn't a member of staff with time ring-fenced to chair that committee, which I'm now doing in psychology, why is that? And again, it may need to be grassroots, bottom up, with you asking your senior colleagues why that's the case rather than waiting for it to happen top down from them. Then there's the third level at which you can take action, and that's the societal level. And outside of science, I'm a member of a political party and I'm a member of Extinction Rebellion. There are things that you can be doing that are part of the wider challenge in this respect. But within neuroimaging specifically, something we can be doing on a community level is something like this new environment special interest group that I want to set up. So the tiny URL link there is just a sign-up sheet to just register interest. So the process for setting up a special interest group is that first we need a number of people, great, thanks, Keeper. We need a number of people on board who are willing to take on specific roles. And once we've got that list, and you need to be an OHBM member, once we've got that list of people, we can send the form off to the OHBM Executive Group and Council, and we can then form the SIG. And one of the options there in the sheet is to specify if you're interested in a committee role or if you just want to be on the mailing list and get updates. So there will be multiple levels at which you can be involved, and you can, just be an active listener for the foreseeable, or you can get more involved if you want to.
Wonderful. So we're dead on time, so I think we'll close there. Thank you so much, Charlotte, for leading this discussion. And I'm really pleased as well. We've had 30 people join up to this discussion, which is almost better than our opening and closing ceremonies. I don't mind. I'm not. Great. I'm really, really pleased, Charlotte, for the effort and energy you put into this, and I'm really hopeful that it does. The conversation does continue. So I've seen a few people have joined the Mattermost channel. And I guess we'll take it from there.